Okay, let's look at an application of vectors. So we have a naval cruiser on maneuvers, and it travels 54 kilometers at 18.7 degrees west of north. So see this 18.7, here's north, and this is to the west of north. So this is where it heads out. Then it turns and travels 64.5 kilometers at 15.6 degrees south of east. So here's north, here's east. It's going to go south of east 64.5 kilometers. This picture is an attempt to be drawn to scale. Finally, it turns to travel 72.4 kilometers at 38.1 degrees east of south. So this direction is south right here. So if we go east of that, the 38.1 degrees, 72.4 kilometers. So one of the ways to tackle this problem, and sometimes I really debate with myself as to how to do this, is to go ahead and find the x and y component of this first vector. So it looks like x is going to be negative and y is going to be positive. I would be inclined to use an angle that's 90 plus the 18. You could use this angle right here and know that this is the side adjacent. So if you use that angle, you'd use cosine again for this, and then this is the side opposite, and use sine of this angle. I'm just telling you though, if you use this 18-degree angle in this picture right here, it's up here. That's where that 18-degree angle is. See this 18 here? It's up here. Those are alternate interior angles. And you'd have to switch your sine and cosines, and it starts to get pretty complicated. If I were to continue on, this vector right here, its x component would go like that. It looks like a positive x and a negative y component. So, and I can use the 15 degrees, or I can use 360 minus the 15. And then right here, this vector's x component would go this way, and then downward to there. It's supposed to be a perpendicular right here. So that's kind of the gist of it. Now, I'm going to go ahead and draw a table of this, and I think I'm going to try to put it right here. And this is how I'm going to tackle this problem. So I'm going to start with this 54 kilometers. That's the magnitude. And instead of using this 18 degrees, I'm going to go 90 plus 18 is 108.7 degrees. So that's an angle in standard position. This next vector, whose magnitude is 64.5 kilometers, right here. If you put a little plus sign right here, just a little plus sign right here, and think of this as the x-axis, then I'm going to call this 15-degree angle. I'm going to take 360 and subtract the 15.6 degrees. So I have an angle that's in the fourth quadrant. Again, this is the x-axis, this is the y-axis, at this particular vector. And so that's 4 degrees, looks like. And then this vector right here. So I put this little plus sign right at the tail of that vector so that I can see it in the rectangular coordinate system, and I can see that this vector right here is in the fourth quadrant. So for me to figure out the size of that from the x-axis to go all the way around to here, I'm just going to go 90 plus 180, 270, and add the 31. So this angle right here, I'm going to go to, it's actually, I'm sorry, it's not right there, it's the coterminal angle. It's 270 plus the 38.1, so I believe that's 308.1 degrees is the direction of this vector from the x-axis. It's 308.1, and its magnitude is 72.4. Now I'm going to erase as much of this mess as I can here. And as we find some numbers, I'm going to go ahead and have you look at the picture up above. So if you found the x component of the first vector, which is this blue one right here, and in the rectangular coordinate system, it's in the second quadrant. So I expect x to be a negative number, and I expect y to be a positive number. So again, you're taking, I'm going to move this negative sign over here, you're taking 54 times the cosine of 108.7 degrees, and you should get a negative 17.3. And then you'll take 54 times the sine of the 108.7 degrees. By putting these in standard position, you can always get the proper sine, 51.1. So again, this is a negative 17 and this is a positive 51. Come down here, you take 64.5 times the cosine of 344.4 degrees. That's in the fourth quadrant. This one right here. It's in a fourth quadrant. If you put a plus symbol right here, that's a fourth quadrant angle. Cosine is positive in the fourth quadrant. Plus the x component of this vector should go to the right and y should come downward. So this one's a positive 62.1, and then 64.5 times the sine of the 344.4 degrees is a negative 17.3. This one right here is in the fourth quadrant as well, so x should be positive. So 72.4 times the cosine of 308.1 gives us 44.7. And then the 72.4 times the sine of 308.1 gives us, it looks like a negative 57. That's kind of odd. It rounds up real nicely to a negative 57. So now, this picture was drawn to scale. I'm expecting my resultant to be like this. All right, that's what I'm kind of expecting. And so now I'm going to turn to the Pythagorean Theorem because my x components, these positives and this little negative, add up to be 89.5. And my y components, these two negatives with this 51 as a positive, turn out to be a negative 23.2. It means that this red line goes to the right 89 units and then downward 23. So to the right 89 and down 23. And so you turn to the Pythagorean Theorem and you find the magnitude of that vector by taking 89.5 squared plus 23.2 squared. You don't bother with those negative signs. And I've got 92.5 kilometers is how far the ship is displaced. The reference angle is the inverse tangent of this y number divided by the x number. Don't start here and here. Its tangent is defined as y divided by x. We're not using the negative sign to get an acute angle of 14.5 degrees. Something acute is between 0 and 90. And then because x here is positive and y here is negative, I know I'm in the fourth quadrant. So in the fourth quadrant, I'd take 360 minus 14.5, which would give me 345.5 degrees. Don't forget, though, that you can report the displacement of this vector to be 92.5 kilometers from its origin at an angle of 345.5 degrees, or you can say that it's at an angle of 14.5 degrees. I believe it would be south of east. Let's go back up there and look. This looks like 14.5 degrees. Here's east, and it looks like it's south of east. Again, the magnitude of this line turned out to be 92. Look at our picture. You know, this is 54, this is 64, this is 72. This turned out to be 92. So from its original position, it went northwest, then it went kind of southeast, then it went a little bit more southeast, and it ended up southwest in terms of my final results right here. Very good.